Well, good morning, everyone, and thank you for attending this, our last in a series of product webinars, Ethernet switches, SFPs, and media converters. My name is Craig Kennedy, and I am the Technical Solutions Architect for KBC Networks EMEA. With us, we have Janine Tucker, Head of Marketing, and Luis Angulo, our Commercial Director. During the webinar, you can post any questions in the chat window, or you can email us at emea@kbcnetworks.com with any questions you have. During this very difficult time, I want to assure you that KBC Networks are still producing products, and shipments from our USA and China factories will continue as normal. There's still selective stock available to ship from our Spain office. You're still going to be able to get support from our USA, UK, Spain, Dubai, Mexico, and China teams. And for all those who don't know KBC, KBC Networks has been trading globally now for over 25 years. During this time, we've won notable awards, including SIA Best Network Support Solution for our ThruLink hardware VPN, and more recently, the ASMAG Buyer's Choice Award for our eCopper IP over coax and UTP solutions. A system is only as good as the weakest link, and today's systems in security and IT need to be extremely robust to be able to deliver reliable connectivity with absolute security at all times. KBC Networks products are designed to meet these robust requirements, while at the same time offer a simpler solution that falls within the customer's budget. All of our products are industrial grade for use in harsh environments with operational temperatures of -40 to +74 degrees. KBC Networks have 6 main product lines. All are industrial grade for use in harsh environments. First, our IP range, which includes our network switches, SFPs, and media converters. Next, ThruLink, our hardware VPN solution with 4G capabilities. Our high throughput wireless system, and our vast fiber optics portfolio for analog and IP signals. And our eCopper, IP over coax and UTP, and finally, our remote power solutions. Many of these complement each other as well. This final webinar is all about our IP products, specifically Ethernet switches, media converters, and SFP modules. Although this won't be a technical presentation, there will be some system drawings in here to give you examples of use. And as I mentioned before, if you have any questions during the presentation, please feel free to post them in the chat window, where myself, Luis, and Janine will try to answer them at the end. Or you can just send us an email, again, emea@kbcnetworks.com. So, the KBC Networks IP product range is made up of 3 parts, all of which complement each other. We have our wide selection of Ethernet switches, our SFP modules, and of course our media converters over fiber. All are industrial grade, which means you'll hear me mention a lot throughout this webinar how industrial they are. So starting with our switches, we have a wide selection of switches available, and to go over them all would take some time, and we couldn't fit even nearly enough on this page. So I've just picked a few selected ones here. We have everything from 4 ports up to 24 ports, or actually 28 ports, managed, unmanaged, PoE, PoE+, and PoE++, all industrial grade for use in harsh environments. We also have some low power input options available. Throughout this webinar, you're going to see similar looking switches where you see a model number with a red N in the product code. This means it's a non-PoE switch. In general, most of our switches can support non-PoE or their PoE versions available. Now, when I say 4 ports, in actual fact, it's a 5-port switch. 4 ports are PoE capable, while 1 port is non-PoE and typically used as an uplink port. And likewise, on a 24-port variation, these are 24 usable standard ports with either 4 additional SFP ports or 4 additional SFP combo ports. So essentially, when I say 24-port, what we're talking about is a 28-port switch. All of our switches are industrial rugged with no forced cooling or fans, so can be used in both extreme hot and cold environments, and are IP40 rated. Now, before we go into the product details, I think it's important that we cover one fundamental requirement when selecting a switch: what questions need to be asked. When looking at which switch you need to use, there are several key questions that must be asked at the very beginning, and the answers will guide you to the right switch for the requirements. Okay, so do you need PoE on a switch? If you're in security industry, then most likely you will want PoE to some degree, since most of the equipment in today's IP-based security systems are PoE powered. How many Ethernet ports do you need? You need to be careful and consider all options, including expansion. You may have 4 cameras, but you may also be connecting a DVR, perhaps a wireless unit. So what initially seemed like a 4-port requirement has become a 6-port requirement. And if 6 is the end number, I would always try and add a couple more ports, so go for an 8-port. If there's expansion later, you can always add a second switch. And then fiber linked or standalone. Now here we're talking about the use of the SFP ports, which typically are going to be fiber-based. If the switch is simply standalone, possibly linked to a central point over a 4G or a wireless connection, then you probably don't need any SFP ports. However, if the switch is going to be linked in some way to a larger network using fiber, which is typical, then you'll need to use a switch with a suitable SFP port. Now, if the answer to the fiber question is yes, then we have a set of different questions to ask, which we'll come to a bit later. It might seem complicated, but it's really no different to selecting the extras on the purchase of a car. What size of wheels do you want? What color seats do you want? Do you need managed or unmanaged? Now, more often than not, the client doesn't. Mute somebody there. There we go. Sorry about that. So do we need managed or unmanaged? Now, more often than not, the client doesn't need managed, but it does depend entirely on the scale of the network and, of course, where it's going. A small car park structure might be perfectly fine using simple unmanaged switches, while a corporate office may need to use multiple VLANs to segregate the security network from other networks, so managed switches will probably be needed. Let me get back onto this. And lastly, low power input. Most of the time, you're going to need a 48-volt DC power supply to power the switch and provide PoE. That's typical of most switches. But KBC do have a 4, a 6, and an 8-port switch available that can be powered from 9 to 36 volts DC and still provide you with up to 180 watts of PoE power. So make sure you ask the right questions to ensure your customers get the right solution, or yourselves. So our PoE switches, which we're going to go over now, are available as PoE, PoE Plus, and we also have a PoE++ switch offering up to 70 watts of power per port. We have 4, 6, 8, 16 and 24 port full PoE Plus capable switches in the range, offering from 120 watts up to 720 watts of usable shared PoE power. 10100 and gigabit Ethernet ports and multiple SFP options from 10100 to 10 gig are also available. PoE is available on all ports with a maximum 30 watts per port available, depending on the power supply being used. I also want to mention power supplies have an approximate efficiency of 90%, so bear this in mind. A 120 watt power supply is actually only offering about 110 watts, and the switch itself is going to need at least 10 watts without PoE. So your power supply is now only able to deliver around 90 to 100 watts of power for your PoE. So if you're using an 8-port switch and you know you're going to fully load it with PoE plus 30-watt devices, go for a slightly larger PSU, something like a 320 or even a 480, just to make sure you're covered. And this is the case with all power supplies. All of the switches, managed, unmanaged, and PoE are IP40 rated. All come with multiple power protection levels, and most have dual input options for power failover. Along with the standard PoE switches, we also have a 4, 6, and 8-port PoE Plus switch that can be powered from 9 to 36 volts, as I mentioned before, rather than the 48 volts DC. We'll show a few examples of those. Our PoE range can be used to power any IP device that uses PoE standards 802.3 AF and AT. Our standard PoE Plus switches offer 30 watts of power, while PoE++ is 70 watts per port. In the security industry, almost all devices now are IP based and are powered via PoE. So being able to offer small 4 and 8 port switches is ideal for outside all-weather enclosures, will be small, or street cabinets. And with DIN rail mounting options on all of our smaller switches, installation is very simple. So here, in this example, what we're using is the low input switches to provide PoE power. These low voltage input switches are perfect when you're using a remote power solution, like our solar solutions or our UPS, where your actual power is coming from a battery, or as I said, like our UPS solution, 24 volts DC. With 12 volts DC, you have a budget of around 90 watts of available shared PoE power, which is quite a good number. With 24 volts DC, it's 160 watts, and 36 volts gives you a maximum 180 watts of available shared PoE power. These low voltage input switches are available as 4, 6, and 8 port, and if you use these with our SPB or UPS solution, we can provide the entire thing inside a single solution, complete with enclosure. Because we have a mixture of both unmanaged and managed with PoE, you're going to see many similar looking switches and probably hear me say the same thing a few times. I apologize for that. Our unmanaged switches are available with 4, 6, and 8 ports, and our edge devices, with 10100 and gigabit Ethernet ports, as well as 1 and 2 SFP options. The unmanaged range are ideal when you need a quick and simple solution, whether linked via SFP or not. The industrial design and IP40 rating of all KBC network switches make them perfect for use in harsh environments. And all of our switches come with several levels of protection, including ESD protection and up to 6 kV surge protection, also overload and reverse polarity protection. It's a very robust and simple solution. Here we have a very simple daisy chain network of unmanaged switches, multiple IP devices connected, all flowing through the fiber network back to a central point. This could be a multi-story car park structure where each floor has daisy-chained unmanaged switches or a fence line. An extremely simple way of linking multiple locations with the ability to scale and no management required. Use of the KBC SFP modules, which are also ruggedized, allows distances of up to 100 km between nodes. And for those locations where you have only mains power, you can make use of our SPB power box, designed to take mains power as an input, 100 to 240 volts AC, and offer you multiple flexible power output options, including housing the switch for you. Need to make the entire install even simpler, providing you with everything needed in one enclosure. And then for those locations, like a fence line application, where you perhaps have no power and you need to consider using solar, you're going to be looking at your low voltage input switches for that unit. So we can provide the solution for all of these. Or you might have a slightly more complex central network where the remote sites can be simple systems using unmanaged switches and media converters, but you need to feed it all into a more complex network configuration. So here we're using a layer 2 managed switch to pull in the multiple remote locations. We have 3 remote points, 2 using a small unmanaged switches and 1 with the media converter. All 3 are sent over fiber back via SFP into the switch, which in turn feeds these into the central point. In this system, we've used unmanaged switches at each remote location and of course a media converter, all coming back into a larger unmanaged switch. But if you need a managed switch, then you at the control point, then you can. And you can have the 8-port SFP managed as well if you really need to. It just depends exactly on what your network requirements are. If you need unmanaged, go unmanaged. If you need managed, we can supply that. So our unmanaged switch range offers multi-site connectivity for those simple network requirements with the ability to provide a complete power solution using our SPB or our remote UPS with solar for those locations with no power at all. In combination with our low voltage input switches, there's really no situation where we can't provide a switch solution with or without power. And if you have multiple remote systems where connectivity back to the central point is an issue, there is no network, we can make use of our ThruLink, which is a hardware VPN using any public network, including 4G, to give you full unrestricted access to all of your devices. Notice the red N there in the product code, by the way, just to reflect the fact that's an unmanaged SFP switch. Okay, so now on to the managed switches. Now this presentation won't be a managed training presentation. Later on we're going to put together lots of videos showing configuration of various options within the managed switches. Today's webinar is going to be more about letting you know what we have available with a few basic system examples. And as I mentioned earlier, many of these switches are going to look very similar to the unmanaged, and like the unmanaged, our managed switches also offer PoE features. So there's going to be a lot of repetition. So our managed switches are all layer 2 switches available with 4, 8, 10, 16 and 24 Ethernet ports with 2 and 4 SFP and combo options. We also have 8 ports and 28 ports full SFP switches available. The managed range are available with support for 10100 gigabit on the Ethernet ports and 10100 gigabit and 10 gig on the SFP ports. Now, like most layer 2 switches, these also include your typical ring protocols, STP, RSTP, MSTP, and of course, ERPS ring protection system. Configuration of the switch is via a web GUI, telnet, SSH, and console. I'm not going to run through the entire specification sheet for all of these, it would just take too long. Needless to say, they are feature rich, but if you're looking for a specific feature, you can email us at EMEA@kbcnetworks.com with your questions on features, or you can just download the spec sheet for any of our managed switches, which contains the same information. And again, though these are managed, they're all rugged in design and can all be used in harsh temperature conditions. And we have an 8-port with SFP switches being used in Kuwait right now. All are in outdoor enclosures where the temperature regularly gets to 70 degrees C, and they carry on working with our ruggedized SFPs as well. So, some examples. In this system, we're using...
Hi, Greg.
Hello.
Good morning. I just want to make one comment to everyone that is participating. One of the unique features that we have here on the managed switch, particularly the 24+4 ports, is if there is a need that for application where every port is connected to an IoT device that requires PoE plus 30 watts, that means that all the ports connected will require 720 watts of power. And we do have that switch available for our customers, right? Typically, the 24+4 switches are around 400 watts maximum power budget. However, we do have the 720 watt power available for applications that require PoE plus in every port simultaneously. Thank you.
Thank you for clarifying that. Yes, we do have a 720 watt full PoE plus switch. And it's also temperature hardened and ruggedized as well, so it can go inside a street cabinet if you want to put it in there, although they are quite big switches. So, back to my system example. In this is a real system, by the way. This system you're seeing on screen is actually deployed. So in this system, we're using an entirely fiber network for multiple remote locations. And because it's, in this aspect, a banking application, we have a redundant fiber network and a redundant switch network solution. So typically where you need to have little to no downtime, like a dual fiber network, gives you a redundant transmit path. So using single 8-port switches at each remote site, which you can see here on the left, remote 1 and remote 2, obviously multiplied by a factor of, I think, of about 100, SFPs are used to create a primary and a failover fiber path. Each path is linked to one of the 2 switches on the right-hand side that you can see. So these are your redundant switches. Path 1 goes to collection point 1, and on remote site 2, path 2 goes to collection point 1 as well. So you have that redundancy in there for the fiber. This gives you redundancy on the fiber, but also on the switches. So if collection point 1 fails, remote 1 will automatically send to collection point 2, which I'm going to show you now. So here you can see what happens when a fiber breaks between remote 1 and collection point 1. In the event that a fiber break occurs, the switch will automatically move data onto the secondary path for transmission until the failed path is repaired. This same rule applies to the physical switch failure. Again, if the switch fails, it will switch the path. Now, if there were perhaps 2 fiber breaks, and hopefully you can see that because I can't. There we go, 2 fiber breaks on the system. The traffic again will simply go down the alternate path. Now, obviously, there is no way to cater for every possible issue, and redundancy can only go so far while remaining cost effective. But in this situation, we're able to provide a redundant path for the data without too much programming, and because our switches are so competitively priced, it's worth looking at using redundant hardware, as we've done here. Then, of course, we have support for STP, RSTP, and MSTP ring protocols. Now, these protocols, for those that don't know, allow you to create a dual fiber ring network. One ring is primary for all traffic, while the second ring is a failover ring and is enabled in the event of a fault on the primary ring. It's obviously a lot more complex than that, but we're keeping things fairly simple at the moment. It is common for security networks to use STP and RSTP protocols for the creation of redundant fiber ring networks. And you'll see these implemented in shopping malls, car park structures, etc., where each ring is tied into a larger switch. MSTP allows VLAN devices to use multiple spanning trees, letting traffic on the VLANs flow over different paths within the network. Although in theory, there are no actual limitations as to how many switches can be on a ring, in reality, STP is limited to around 20 nodes, while RSTP can be around 40. However, you're going to read and see many variations on this. Some companies are saying STP is 20, others are saying 100. But as a simple rule, try not to have a big ring. STP at 7 to 12 is a nice good number, and RSTP can be up to 35, 40 without any issues at all. And then, of course, we have ERPS support, Ethernet Ring Protection Switching. In simple terms, ERPS works similarly to STP and RSTP, but supports far more complex networks and offers a higher level of redundancy and faster recovery times in milliseconds rather than seconds. The concept behind ERPS is pretty simple. Switches are connected in rings. Subsequent rings are connected to each other by joining 2 switches from each ring. This ring redundancy is what offers the much faster network recovery, while ERPS system itself manages the system to make sure no looping takes place on the ring. All of our managed layer 2 switches support ERPS. And lastly, a slightly more complex setup to reflect multiple topologies, all converging at a single point. Here we have a complete end-to-end fiber optic transmission solution using a mixture of unmanaged and managed switches. So we have remote locations using our 8-port unmanaged switches linked to the centrally managed switch via SFP ports. Media converters, which are all linked back to an 8-port all SFP switch, which in turn links back to the centrally managed switch. And then we have an RSTP ring network, also linked back to the centrally managed switch. And these are then fed straight into the core network. It's just showing multiple different connectivity types.
Hey, Craig.
Yeah.
I just want to make a brief comment here on this slide. It's a little bit away from the topic. On the bottom right portion of the application, we have media converters. I just want to give an example. If you, in case you have a device that is over 100 meters away from the switch using your Cat 5, 6, or 7 cable, if you require additional distance, you could see these media converters replace as a e-copper product line. there are some applications in which the campus or the central facility have cable runs longer than 100 meters, 200 meters, 300 meters, or old existing telephone cables, and we could use those to provide that information to the switch. But instead of using a media converter, we will use the e-copper product family there. Thank you.
Thank you. And to be honest, we could have expanded on this even more by adding fiber from the e-copper, even going further. So there's all of our products can provide you with multiple different solutions all tied together. I mean, this drawing could be huge if I really wanted it to be, but it would be quite complicated as well. So I'll get back to this. So there we have our switch range. Obviously, I haven't included every single switch we offer. On our website, we have a switch comparison chart that you can see here on the right-hand side. The link is at the bottom here. You can just make out that address, hopefully. This chart will help you find the switch you need much, much quicker. It's listing all the different components that you have, and you literally can click on the link and download the specification sheet for it, or go straight to the web page for it. It makes it very simple to actually find the switch you need. We're going to expand on this as well to make it a bit simpler. And of course, our specification sheets are all available for download and contain all the technical details of each switch from the KBC Networks website, or you can email us again at EMEA@kbcnetworks.com with what your requirements are, and we'll send you the specification sheets you need or answer your questions. So now, moving on to our media converter range. We have covered this in previous webinars, but because it's both fiber and Ethernet, I'm going to go over it again. Our media converter range is what you can actually see here. Everything from 1 and 2 fiber solutions to SFP options with PoE or without PoE, and dual Ethernet options as well. So here we have the 10100 options from the standard with or without PoE, our dual 10100 Ethernet port unit, or the SFP option. They all support 1 or 2 multimode or single mode fibers with transmit distances of between 2 and 20 kilometers, depending on the fiber. And if you use an SFP model, we can offer up to 100 kilometer distances and some more. I believe we can do 160 kilometers. Most of these are available as DIN rail or chassis mount. You can see some of the specifications here. And then we have our gigabit range. Again, very similar spec to the 10100 options. Only these are all gigabit models, 1 or 2 multimode or single mode fibers, and also dual Ethernet and SFP options. And remember, our media converters can link directly to a network switch. So you can plug these in via SFP directly into an Ethernet switch. And then the rack options. We have a passive rack, which is the FR2-12, designed to allow the standard units to slide right in and keep things a little tidier, while the FR216 is a fully active rack with an optional dual PSU for redundancy, supporting 15 or 16 slots. And both the FR212 and 16 are only 2U high, so they don't take up a lot of space in your cabinets. The standard media converters have a loss budget of 12 dB, which equates to 2 kilometers on multimode fiber or 20 kilometers on single mode fiber. Now remember, the distance is based on the loss on the fiber, so if possible, try and check this in advance. Our budget is very conservative, so you're more likely, if your fiber is very good quality, you're probably going to get a further distance than what we specified. And all non-chassis media converters come with a suitable 12-volt DC power supply, except the PoE units, which of course need a 48-volt DC power supply. And the SFP-based media converters, they're a little different. The distance achievable is based entirely on what SFP you're using, and you always need to use matched SFPs, but we can help you with that. Our standard SFP wavelengths are 1310 and 1550, for those who understand. We can offer others if you need our SFP to communicate with non-KBC ones, but we do need to know in advance. And again, they all come with a 12-volt DC power supply, except the PoE units, which of course need the 48 volt DC. A typical application we see often, point-to-point media converter links going directly into an SFP switch. And media converters are extremely simple. There is no programming. They literally are plug-and-play systems. So the media converters are available with standard optics, where the budget is defined, and SFP units, where the budget is based on the SFP used. On the standard media converters, we typically have an ST connector, but we can do ST, FC, SC, and LC. And on the SFPs, we are somewhat limited. Distances on the standard media converter are 500 meters up to 100 kilometers, depending entirely on the throughput needed and the SFPs used. And don't forget, fiber loss determines the maximum distance. All non-PoE units come with a power supply, and all units have LED status indicators, so you can see what the units are actually doing at a glance. Now, I mentioned at the very start, there are key questions to ask when looking at fiber. So here we have it. Sorry, no, this one we have it. I'll go back on this one actually. I apologize, I've skipped a slide. So all our SFPs are industrial hardened. Something to remember is that if you use a commercial SFP in an industrial environment, once it gets beyond a certain temperature, it's going to stop working. So always use industrial hardened SFPs. And ours can support up to -40, down to -40, sorry, and up to +74 degrees. So they're perfectly suitable for these harsh environments. And as I mentioned before, on the SFPs, the LC is the default connector, mainly because they're much smaller. SC is available, but only on a one fiber version. And again, the distance on the SFPs is limited by the loss on the fiber. So if you can check that, that would be good. Typically using 1310 and 1550, but as I mentioned, as you go higher up in terms of bandwidth, so the 10 gig SFPs, for example, will use a slightly different wavelength. So always keep us in the loop if you're going to be using different SFPs. So selecting the right SFP module. This is kind of important as well, because if you get it wrong, you end up with SFPs that aren't going to work. So first, what speed are you after? 10100, gigabit, or 10 gig? And bear in mind the switch you've got may not support 10 gig, so also check that one. And then the fiber type, multi-mode or single mode. There are really only those two. And then how many fibers do you actually need? 1 or 2 is typical. A one fiber solution, so I'll skip back a bit. A one fiber solution is going to result in 2 slightly different models. Now I'm going to go over this and hopefully it won't be too confusing. An A side and a B side. For example, an SFP called MS1A is a one fiber single mode SFP module and is the A side of the link, transmitting on 1310 and receiving on 1550. The key part here is the MS, so MS, S is single mode, 1 is one fiber and A is the A side of the actual link. So MS1A means it's the A side and it's a one fiber. And the matching SFP for the other end of that link will be MS1B. It's exactly the same, but the B determines it's the other end of the link. And it transmits on 1550 and receives on 1310. So you can see they're a matched pair. While selecting a 2-fiber option will result in a far simpler product where both ends remain identical. For example, SFP GM2. It's a 2-fiber option. It's a multi-mode 2-fiber option, and both fibers transmit and receive using the same wavelength. Obviously, a 2-fiber option is going to be a little bit easier for you. Then we have connector type. And again, there's only really 3 options, and only 2 are relevant at this stage in the questions. LC or SC. And if using SC, you're only going to have 1-fiber options, while the LC is much smaller connector type, so offers 2-fiber options. And the third option, which isn't fiber-based, is an SFP with an RJ45 connector. So if you need to turn an SFP port into a standard Ethernet port, we also have those modules in 10100 or gigabit. Conversion means your 8 or 10 port switch with 2 SFPs can suddenly become a 12-port switch. And lastly, how far do you need to go? The distance available is going to be based on the fiber type and the throughput selected. A single mode unit can achieve distance in excess of 100 kilometers over just one single fiber, whereas a multi-mode unit using one or two fibers will be a maximum 2 kilometers, again based on fiber losses, potentially more than that. And that's a 10-100, while gigabit on multi-mode is going to be 500 meters, again based on fiber loss. So if you're looking to go distance with gigabit or 10 gig, then you're going to be using single mode fiber. And as we go further and with the higher throughput SFP modules, the wavelengths used are going to change from the standard 1310 and 1550. So also check the spec sheet and bear this in mind if you're going to be linking our SFP to another manufacturer's switch or SFP. Contact us with the wavelengths you need for your SFP to communicate, and we'll make sure you get the right one. Our SFP models are all hardened with operating temperatures of -40 to +74 degrees. And as I mentioned, it's very important that you remember that. They're available with LC and SC connector types, as well as RJ45 if you need it. Distance is always limited by the loss on fiber, and the more common use SFPs operate 1310 and 1550 wavelengths, while some on the gigabit and 10 gig optics use different wavelengths. But always check the spec sheet to ensure you get the right ones. And if you aren't sure which one you need, email us at EMEA@kbcnetworks.com, including as much detail as possible. And remember, in most cases, you're going to be looking at using SFPs in a non-conditioned environment. So using a commercial grade SFP in a harsh environment, it's going to fail. So go for the rugged options. And we are very cost effective. Our prices are very good on those. KBC Networks is known for its product quality and even more for providing fast and detailed support. Our team will always assist you with product selection guidance, system design, and product support. We have specific warranties for each product family, detailed terms and conditions available on our website. Basically, switches and fiber products have a 5-year warranty. However, we have many installations where these are still operational after 15 years. For e-copper and media converters is 3 years, and 2 years for our ThruLink, wireless, and power products.